Yeah, good morning. Thank you everyone for coming. I'm very, very excited to be here. And my name is Ray. I'm a cloud developer advocate from Google. And what I do is to bring some of the latest and greatest technology to developers around the world. And the other thing I like to do is to hear about your experiences and how you're using our technology today. So the best way to reach out to me and provide me some feedback and just talk is via Twitter at Satanism. Now, how many people here know about Google Cloud Platform? No, very few, very few. Oh, wow. Okay. So yes, Google has a cloud platform that you can use to, run your virtual machines and run many of the managed services that we have to process a lot of data for you. So it's something that's really worth looking into. If you haven't heard about this before or you haven't used it before, please try it out. But today I'm going to talk about Kubernetes, which is a project that Google started previously. Okay. And it's my very first time here in Lugano, Switzerland, so it's absolutely wonderful, and thank you so much for having me here. It's such a beautiful place. That's the photo I took yesterday as I was coming in, so I'm very, very happy to be here. Now, aside from technology, I've been a Java developer and enterprise architect for about 10 plus, almost 15 years, and prior to Google, I was working at Red Hat in middleware and consulting prior to that. Aside from technology, I love to travel. Now, that's where I like to be, and this is a couple years ago when I was a backpacker. I was traveling in Asia, and I was hiking, walking around, just visiting places in China, in northern China. And I came about to this city where they didn't let me stay in any of the hostels. I had no place to stay in the evening. So somebody told me, hey, if you really want to be cheap, because I was a backpacker, and if you want to stay somewhere for free, there's an idea. You can actually go to this desert, and you can hike for about 4 hours in the desert in this southwest direction, and you actually find a real oasis with water and everything, yeah, and you can stay there for free. Yeah, I don't know, anyone here hiking the desert before? There's always a few people. No? Yes, I see, I know there's always some. For 4 hours? No. 4 hours, 4 hours straight. Yeah, yeah. There you go. And it's not easy. It's a little scary because after about 2 hours, when you look back, there's like nothing. When you look to the front, there's nothing. It just looks like that everywhere, and it gets a little scary. And hiking the desert, for those of you who never tried it before, it's like if you go to the beach. It's not like that. It's the sand is really soft. Every time you take a step forward, you sink a little bit, and you have to pull yourself out. And when somebody tells you to go to one direction, you go that direction no matter what's in front of you. Okay, so if there's a huge sand dune, you go up and you come down. It was really tough, and it really reminded me of the days when I was writing J2EE applications. That's yeah, I heard some applause. No, But the end was beautiful. This is actually at the oasis after I got there. It's absolutely wonderful. I forgot whether this is the morning or the evening because they all look very similar, but it was beautiful. And so part of my job is actually to, make sure that the developers who are developing your, application or business or whatever, you get to this beautiful place in one shot. Like I want to airdrop you. I want to take you on the helicopter to get you here rather than having you to go through the difficult, the steps where you may actually have to get there. Okay? So I think everybody here may already know about microservices and all that stuff. So the talk here today is really there's no theory. No, I'm just going to do a lot of the show and tell. So there's no theories here. If you make up your mind, it's whatever you decide. But I want to make sure that you get a sense, a feel. You get to see what it is like to run, your applications or services or your infrastructure with Kubernetes. So let's go straight into the demo application. This is probably the most beautiful application I ever wrote. I'm not a front-end UI developer. This is the best I can do with Bootstrap. But it has two services behind it, okay? So it's got a front end and two back end. And basically what you do is very simple to demonstrate some of the concepts. If you press the button, it's going to save the data into a database via a service, and it says hello to you. So it's a guest book plus a hello world, best of the two demo applications put together. And this is what it looks like behind the scenes. there's a service and talk to the database, whatever. And I'm also using a Redis for session replication. Now, imagine how you would deploy this application before, and for many people, how you do this today, is that in many cases, we package them together into a single deployable, right? And then you deploy this, everything's fine. But what you have to remember also is that before you can deploy this application, what do you have to do? Now, as a consultant, many years ago, before I can even start a project, I have to tell the line of business how many machines I need. Okay, how many machines do I need for production? I don't know, like 20. And then how many machines do you need for staging? Like the same as production. And then how many do you need for QA or testing? Divided it by 2, 10. And then for development, whatever. You need to know about these things or kind of guess how many you have even before the project starts, because it will take many months for them to provision it to get you the machines. In my days, it was like 9 months. Okay, I don't know if anyone can get a machine in like half a year, in 1 month. Anyone here? No, yeah. So that was a challenge. But once the machine was here, then you have to install the operating system, right? You have to rack it, you have to cable it, you install the operating system, you configure the operating system, you have to optimize it, and then you install some of the basic libraries or dependencies with apt-get or yum, whatever, and then you install your application server, whether it's Tomcat or Wildfly, JBoss, WebLogic, doesn't matter. And then you configure that application server with configuration files and Jindy, and then finally you maybe deploy your application, and then you find out that it probably doesn't work. Yeah. and then you have to fix it, right? Because most of the time there's this huge runbook, a documentation on how you actually set up the environment, and somebody has to follow that. And you could script it, you could also script it, but it's still the same thing that you're thinking about. But if the script is messed up, you'll mess up every single machine as well. How many people have this situation happen to them before, where you have everything's working on your laptop, everything's working perfectly fine in QA, it just doesn't work in production? Yeah, yeah. But what happened? What happened? It was probably the environment, because your environment in your dev was completely different from the environment you're running your production environment. So there are many things that we can do now today to make sure that doesn't really happen as much. Now, how many people here know about Docker containers already? Docker containers, yeah, maybe half of the room. Okay. How many people use container, like hands-on used it? Okay, cool. So I think that will help me determine what I'm going to show later. All right. So with microservices, of course, you will be potentially running many of these components separately. And now, instead of just one package that you need to manage and deploy, over something you're looking at the front end, the back end, 2 back ends, and the SQL Server, whatever. Then you have like 3 packages you have to deploy. And of course, you don't run just one instance of those applications. You run multiple instances of them. And then you can scale them out independently from each other as well. So now you're looking at least 6 deployments, 6 instances. If you run 5 of each, you're looking at 15 instances. If you have 6 services, then you just multiply. This problem gets very complex. If you need to manage that many instances of applications by yourself without any tooling, it's going to be very, very difficult to do. And also, when you're running this many instances of something, when you're running these services independently from each other, you have to deal with many of the other problems. For example, what about port conflicts? You don't probably want to run a single instance per machine. You probably want to run multiple instances per machine, and then you have to manage them. And in most cases, I have seen this. There's a spreadsheet of what application is mapped to what port, right? And you have 4 instances of the applications, and then they each map to different ports, right? So you have to manage that. And then how do you make sure that the services are up and running? How do you check for the health of all of the services that's there? How do you scale them? How do you deal with different environments? There are many, many things you have to think about when you're dealing with microservices. And without tooling, these will be very difficult to do. All right, so let's see what it looks like and feels like when you do one of these things with the tool that I'm about to show you. So since many people here has not seen containers before, So I'm going to do I'm going to show you something here. So here I have a service here. It's just a very, very simple hello world service. Okay. And very, very, very simple. I took it from a tweet from Josh Long, and then I enhanced it a little bit. Okay, so the service, this is what happens. It's going to say hello to you. It's going to return a greeting, and the template of that message comes from a configuration file. Okay, it's also going to tell you what host this service is running on. And the configuration file looks like this. Basically, it says hello with the template name and host name and blah. And this application is written in Groovy and also running with a Spring Boot. How many people heard about Spring Boot before? Ah, there we go. Okay, so many people seeing it. Okay, fantastic. So with Spring Boot, right, you can just simply run this Spring run, and then you just launch everything for you with the service that's running inside of a Tomcat container. So you don't actually have to install Tomcat separately. You can also, for example, just jar it, right? You can create a jar file, and then it's going to take all the files together, compile it, get all the dependency together, and then put that inside the jar file. So now you have a self-executable jar, but you still have to deploy this somehow. What is Docker can do for you then is to make sure that the runtime environment for this Java application it's consistent and it can be pre-built. Okay, so I'm going to show you, for those of you who have not seen Docker before, a very simple configuration file to build a Docker environment. So here I have a Docker file. Let me see. Yep. So what a Docker file can do is that you just list the instructions that you need to do, that you need to perform to create the environment for your application to run. Okay. Traditionally, this is like a scripted thing where you have to run the same thing on multiple machines, or somebody has to perform these instructions on multiple machines. With containers, you basically specify these instructions in a single file. It's pretty self-explanatory, it's self-documenting, and then you can just build a container image based on these instructions. And then this image is like this big blob of static file, like say 300 or 400 megabytes large, or it can be very small. It can be like as small as 50 or 60 megabytes. And then you can just deploy this image everywhere, anywhere you want to run this, and you will always have the same environment wherever you run it, okay? So what you do is you list out all the instructions to set up your application, and then you say, how are you going to run this? And I took these instructions basically from the website on how you install Groovy and how you install Spring Boot. And so I just copy and pasted those instructions here, and there you go. And then I can start building the image like this. I can say this is a test image, and then I can send in the files here, and I can just build a container. And once I build it, oh, this one didn't work. I'll show you another one that actually works. Once you build it, then you can actually run the container. Now, how many people here have used Maven? Use Maven? Oh, also have the room. Groovy? Grado, yeah. There are some people who didn't raise their hand. Ant? That's okay. Yeah. That one time I heard batch scripts. Yeah. BAT files. But I use Make. I use Make a lot of time myself. So if you're using Maven, or in some cases Groovy, what you can do is to use rather than writing the Docker file yourself, you could potentially just use a Maven plugin. And this particular one is from Spotify. And they have actually two plugins. This is one of the ones where you can actually specify how to build your Java application container image directly within the Maven's pom.xml, which is fantastic. So you can say the base image is Java 8 application, and then which files you want to include in your container, and then how you're going to start it. Okay. But the best part about this is that you can actually tie in the build of the containers directly within the phase, the Maven build phase, right? So whenever you are packaging your jar, you can also trigger the creation of your container, which is really, really useful. And in some cases, you can also tag your jar file, right? Your jar file has a version number. You can also make a version number for your container as well, or you can also use timestamps for your containers, and you can add a tag to that, which is really nice. Okay, so I already have a Docker container here. So this application, which is in Groovy, And this Docker file only has about 3 lines. That's because I cheated a little bit. I'm using another construct called unbuild. Okay, so I'm not gonna go into detail right now, but basically what this is going to do is I can inherit another Docker base layer, but as I'm building this new image, that base layer has additional instructions to build my application. Okay, so I can get rid of a lot of the repetitive instructions. I can just inherit it from the base layer image instead. Okay, so what does this look like? Well, let me see, do I have it here? Okay, yeah, I do. So I can do a Docker run, because I have the image already made. I can do a Docker run, and I can bind the port to something, but I'm not going to do that right now. But let me just show you. So instead of using, say, Spring run directly on your host machine, when you have this image, you can just specify the image, Docker image, and then you can just run it, right? And this will be consistent wherever you deploy this, because that container image has all the environment that you need to run your application. So you don't have to reinstall your JVM everywhere you try to deploy the application. It's all self-contained in the image itself. But if you have a more complicated application like the one I had, then how do you actually deploy and run those, especially in the microservices world on your local machine? What I use personally is using a Docker Compose, okay? And this is a way for you to, in a development environment, for example, to really easily specify what images you want to execute and how are they interrelated. So in this case, I have like 3 dependencies. So I can say the UI needs to use the hello service and the guestbook service and Redis. And then rather than install my SQL on my machine manually, I can just do a Docker Compose up. And what it's going to do is through Docker, it's going to download the MySQL installation for me as an image. It's going to download Redis for me as an image. And then it's going to, again, download all the images I created and then launch them all together in one shot. Now imagine what it used to take. When I was developing an application previously, when I joined a new team or a new company, I would probably spend like a week trying to set up my development environment, right? Just configuring my SQL would take me like a day or half a day because I need to get the right credentials. But in this case, everything just started to run. And hopefully, if I go to Docker Machine Dev, I should be able to see my application for the first time. And it's really, really easy to do. This environment is repeatable. I can do this many, many times. Hello and greet. There you go, right? So all of this is running in an environment in my, say, my own laptop in a single machine. Now, the question then is, well, how do you actually deploy this at scale? How do you actually deal with all the issues I talked about previously? And this is where I need to go back to the slide a little bit. Let's see here. And let me go to the 100 slide. I'm just kidding. Here we go. So what do we do actually at Google, and why am I here, right? Once you have to containerize your application, it becomes almost like a deployment and a management issue, right? And how do you actually do that? Well, at Google, we run everything in containers, and we've been doing that for a while already. We're not using Docker container, for example. We have our own container format. But many, many years ago, Google actually contributed the fundamental container technology, which is called C group, into the Linux kernel itself. Okay? And many of the container format today is using C group as the underlying technology to help you to isolate your processes in terms of resources. That's very important. Because in container technology, you can actually run multiple processes on the same machine in such a way that they don't interfere with each other when you have, like, say, CPU load issues or memory issues, right? In my old days, I run everything a single machine in my startup, right? But you can imagine if one process runs away, that's taking up 100% of CPU, it will affect every other processes on that machine. Well, with containers and resource isolation, that situation doesn't really happen. So everything at Google runs in containers. We're not using any virtual machines. We isolate the resources and everything within containers as well. We launch and manage about 2 billion containers per week. And you're like, well, 2 billion. Well, it's actually not many because this is United States billion, okay? It's not the European billion. Because I think European billion, it means 1 million, right? This is actually only 1,000 million. So we're not a million, it's only 2 billion in United States term. So we know how to manage, we know how to orchestrate these containers within Google. We have a lot of experiences in doing that. And everything does run in containers, even like search, YouTube, Google Cloud Platform, in fact, runs in containers. Think about that, that's really, really cool. And this is what we do at Google as a developer, as an engineer. If I want to deploy something, I don't say which machines I want to deploy to. Okay, that's a very traditional way of thinking, because usually you have, like, say, 10 machines, you have app 1, app 2, app 3, right? And you say, I need this application to deploy to app 1, app 2, app 3, whatever. And somebody actually performs that deployment. At Google, we write a descriptor file to describe what the application should look like once it's deployed. And we specify a cluster of machines to run on. We don't say individual machines, we say a cluster. In Google term, we call it a cell. A single cluster can be composed up to 10,000 machines. Okay, so it's nearly impossible for us to specify which machines to run on. We just say we can run in this cluster of machines. I don't care which one in this case. And then we can specify the binary we want to deploy or run, parameters, and the requirements in terms of RAM and disk and the CPU, and they will be isolated, again, in container, not in a virtual machine. And then we can say how many replicas, how many instances do we want to run. And if you need more instances, if 5 is not enough, if you need, say, 10,000 instances, you just update the number to 10,000. It doesn't matter, right? If you need to scale this down to 500, you just say 500. It doesn't matter. And then what happens behind the scenes is that we upload the binary into a central repository, a central file system of some sort. That configuration file gets sent to our internal tool. This is internal. The tool is called Borg. Borg is the tool that manages our cluster for us. So we send the configuration file to Borg, and Borg then will check the scheduler against the scheduler, which then will essentially check with all of the machines under the cluster to see if those machines have enough capacity to run this particular application, which in our case, I need 100 megabytes of RAM and 10% of the CPU. And it's going to check, hey, do you have that capacity? And if you do, it's going to then tell that machine to download that package and start launching it, right? If you don't, then it's going to skip over you and it's going to move on to the next machine and figure out which machines are the best. And then eventually, you will actually see the application popping up in our data center. And we can do this extremely fast. For about 10,000 instances of this particular application, we can launch all of them in about 2.5 minutes, give or take. But that's because also we have very, very fast network. Now, when you're dealing with containers, what you're going to find is that some of these images can be very, very large. You need a lot of network bandwidth to transfer them, to deploy them at mass. So at Google, we actually have very, very fast internal networks. We do about 1 petabits per second bisectional within our data center, so that we can actually transfer these data around. And again, if you're on Google Cloud Platform, for example, you get that advantage because we're running the same data center anyways. But think about it, because in the entire internet, if I read correctly, it runs about 250 terabits per second. But inside our data center, we're doing 1 petabits per second already. So that's not bad. This is like, you're thinking, well, that sounds pretty cool, right? But I'm still in the desert. and you can see over there, that's the tree line to the oasis I'm trying to get to, okay? So how do we actually get there, right? And that's my job today, which is to show you about Kubernetes, right? How many people here heard about Kubernetes? I just want to see a hand again. Okay, not that many, fantastic. So Kubernetes is an open source project that initially was led by Google, and it was created by the same engineers who actually work on Borg. Okay, it's fully open source, and now it's actually part of the foundation that's looking after the Kubernetes project. So it's not something that's fully owned by Google anymore. And Kubernetes as the project, it can actually run anywhere. It can run on Google Cloud. It can run on other people's cloud. It can also run on bare metal in your own data center, which is really nice. And what it is a container orchestrator. It's heavily influenced by the experiences that we had in managing our containers within Google, and by Borg, our system that we run inside of Google as well. And the project is on version 1.2 right now. And as you can see, there are many partners and people who are interested in it. Here's the thing. There are actually now more contributors from outside of Google than Google ourselves, which is really nice. That also means that this project is really community-driven. And you can join a Slack channel to talk to any of the engineers who's working on it. You can also check out the documentations. You can add issues. You can participate in this whole open source community today very easily. It's fantastic. So how does this work? Well, it was especially easy for me to make this slide because all I had to do was copy and paste the previous one and do a string replace. So I just replaced all the words with Borg and with Kubernetes, and this is how it works. Rather than a static binary that we built internally, with Kubernetes, you run a container image, which I kind of just built and ran. And then you push the container image to a container image repository, or registry, whether it's Docker Hub or your own. And then you can also write a configuration file, and then you push the config file into the Kubernetes master, and that checks against the scheduler, and then which in turn checks with all the machines that you have under the control by Kubernetes, and then it's going to figure out where to deploy and how to deploy it, and such, right? So it works very similar to how Borg looks like. And here's a very simple example of a configuration file that you can write. But rather than going through the slides, I'm just going to go jump back into the demo. Okay. So now I have this Docker run. So here's the image that I created previously. It's a hello world image. Okay. How do I actually deploy this to a cluster of machines? And to show you how I'm going to do it, I'm going to show you also a visualization tool. Okay. So right now, I have 4 virtual machines running in Google Cloud Platform. And they are all managed by Kubernetes right now. And in Google Cloud, we have a managed service called Google Container Engine, which is like a managed version of Kubernetes. But again, you can run Kubernetes on your laptop if you want to. This is just for me to do my demo for today. So how do you actually do this? Well, since I have already built an image, if I want to deploy it onto these machines, what I can do is do a kubectl run. Kubectl run, the name of the service, which I can name however I want to. The name of the image I want to run. In this case, I want to run my Hello World service. And here's something that's very important. -L, that means I want to specify a label. Now, label is very important concept in Kubernetes. You can label anything, any resources in Kubernetes, and you can label. You can create a label however you want. So for example, I can say this is version equals 1. I can say this is conference Vox Ticino. I can say environment is equal staging. Right? The key and the value is something that you can make up yourself. And the importance about the label is that you can actually query it later. So later you can say, show me all of the application who has a label of app is equal to hello world service. Show me all of the application whose environment is equal to staging. You can do that. You can do a select. And that's very important when we move on to the next level, which is what we call a service. Okay? So I'm going to start this application with these labels and with this one container. Okay, so let's see. Here we go. Okay, very good. So this visualization tool then showed me that I have deployed my application onto my cluster of machines. And you can see here the box in gray, that's actually the application I'm running. And you can see that this application has an IP address. You can also see that it's running on one of the nodes, TPLA. That's one of the 4 nodes that's under Kubernetes control. And then you see a box that's in blue, okay? So the box in gray, this is what we call a pod, okay? Now, that's a very important concept to understand when you try to understand Kubernetes, is that the pod is the atomic unit that Kubernetes can manage. Now, you may be asking, hold on a second. I thought we were talking about containers all this time. Now, what is a pod? A pod is really a grouping of containers that's tightly coupled together that has to live and die together, okay? And every pod shares the same resources in terms of IP address and value mounts. I mean, you can share the value mounts. Okay. And every pod can have a unique IP address as well. But then you'll be asking, well, what would you want to run in the same pod? In our application, we have the front end, the back end, and MySQL Server, right? They're all containerized. Now, you may be thinking, well, maybe I can run all of those 3 containers in the same pod. Would that be a good use case? And the answer is actually no, that wouldn't be a good use case. You don't want to do that because they're not tightly coupled together. When your application dies, you probably don't want your MySQL Server to die, right? And vice versa, when you are expanding the number of instances of your front end, you don't necessarily want to increase the number of instances of your back end, okay? So that's a bad use case. A good use case could be something like you have an application that's spitting out some kind of metrics, and then you have another agent within the same pod that's collecting the metrics and pushing it somewhere else, right? So in terms of pod, the best way to think about it is like a tiny virtual machine. What would you run on the same machine is probably what you want to run in the same pod, okay? And the box in blue, that's what we call a deployment, okay? And deployment, I'm going to simplify this a little bit. Basically, I can tell the deployment to deploy a new instance of this application. I can tell the deployment how many instances of the application I want to run. So for example, if I don't want to run just 1 instance anymore, if I need to scale this to, say, 2 instances, I can say kubectl scale deployment, my service, and then I can say, replicas is equal to 2. And remember what's happening behind the scenes is that Kubernetes is going to check with all the machines and figure out which machine has the capacity to run this, right? And I can also say, rather than 2, I need 4. And again, it's going to try to find the machines to run it. And if you look carefully, it's actually going to try to schedule these applications out as evenly as possible. Now, another thing that Kubernetes do is to actually make sure that when you say you want 4 instances running, there's always 4 instances running. What happens when one of these machines dies? Kubernetes will detect the machine failure, and it's going to reschedule your application to another healthy node so that you maintain the number of instances as you specified. So we can actually simulate this. So I can say, let me get a list of the application instances that's running right now. I'm going to just go ahead and delete it. Okay. Now watch very carefully of what's happening. If I delete this pod, I have 3 now. But did you see that? It was a little bit too fast. Yeah? It changed a little bit, right? But what happened was that I deleted the pod. Kubernetes realized that now there are only 3, but I need 4. It's going to very quickly restart it for you, okay? So in terms of failures and resiliency, Kubernetes can actually manage it for you. Now, another thing you're going to notice is that these IP addresses are unique per pod. Okay, you can actually see there's 03 and 04 and 3.3, whatever. And then they're also running on different physical machines. They're running on different virtual machines. The beauty about Kubernetes is that every of these IP addresses, even though they're running inside of VM, they can also talk to each other as well. So there's this inter-pod networking you can just do right off the box, which is really, really useful. But one of the things you might be thinking, okay, now I have 4 instances running right now. The IPs changes all the time. They're ephemeral. They're not static. And I can scale out. I can scale in. How do I load balance this, right? Usually, you probably run a load balancer in front of your application. And in Kubernetes, load balancing is kind of a first-class citizen. It's a first-class concept that you can use. And the way that you can load balance this is by exposing this as a service. So what you can do is to say, kubectl expose the deployment, which is the box in blue, which inherently manages all of the boxes in gray, the pods. And then you can say, I want to expose port 8080 and target port 8080. And I'm going to keep this later, okay? So I'm just going to go ahead and expose this. And then what this is going to do is to create a service, which is in green. And that has a stable IP address, which you can then talk to. And that then inherently load balances your request to all the pods that's running. So if I were to scale this out or scale this in, it doesn't matter. The Kubernetes will know about this and will update the service implementation as well. And it will always be able to route to the right instances that's under the control of the service. Now, how does the service actually pick and choose which pod to route the traffic to? The way it works is by using labels. Okay, this is very, very important. So for that green box, for the service to know where to route the traffic to, is by the fact that it's selecting the pods by labels. So in this case, my service is exposing any of the pods which has the name app is equal to hello world service, and visualize is equal to true, just because I'm visualizing it. So then how do you actually contact it? So what I'm going to do is I'm going to do a get pods here. And just like Docker, where you can actually go into the container to execute something from within the container, in Kubernetes, you can do kubectl exec. So I can actually go into one of these pods, one of these containers that's running right now inside my cluster. Now realize this. This container could be running on any of the boxes, but rather than SSH into that virtual machine, I just do kubectl exec, the name of the pod, and bash. Oh, do I not have bash there? Oh, sorry. I need to do a TI so that it's interactive, so it stays. So I do a TI, and I can go into that pod, and now I'm inside of the container that's running in one of the machines that's running and managed by Kubernetes. And from inside of Kubernetes now, what I can do is I can do a curl, and the IP address of that service, and I can say hello. There you go, right? But for service discovery, you probably don't want to keep track of these IP addresses. So what you can do alternatively, and this come out of the box with say, Google Container Engine, you can also have the same feature in any of the Kubernetes installation, is you can use a DNS name, which is really handy. So you can say, hello world service 8080, hello Ray. And that will get resolved to the IP address that I just provisioned with the service, right? It's very, very easy to do. Now, that was too easy, so I'm going to go ahead and deploy my full stack application now. One of the things I'm going to deploy is MySQL. And MySQL actually has state. You actually need to use a disk. You actually have to store the data somewhere, because otherwise it will disappear when you restart it. So for me, for that, it's a little bit more complex. But rather than running the MySQL container directly from the command line, I actually wrote a descriptor file to tell Kubernetes how to deploy MySQL. And the takeaway here is that you can specify the number of instances you want to run. For MySQL, I can only run one instance right now. And you can specify the name of the image you want to run. And in this case, I'm going to run MySQL 5.6. You can specify the environmental variables, the ports, and here's the important thing, the volume mount. So you can define where the volume is located, and we support multiple ways for you to mount a volume. So you can do a host file system. In the cloud, you can do Google Cloud Persistent Disk, which you can provision, and then you can just refer to it by name. In your own data center, you can do RBD, you can do iSCSI, you can do NFS, and there are many, many other things that's being supported. Once you have specified the volume, then you can just mount the volume inside of the container, okay? Or in this case, inside of the pod, and the container running inside the pod. So I can define that. That's not a problem. And let me just go ahead and start it. So I can do a kubectl apply, MySQL deployment. I'm also going to deploy the service. Remember, service is the IP address I need to get into via the that my application can get into. And I'm going to do a record, because I want to record this deployment action. And then what happens then is you see MySQL up and running, just like that. And again, it's pulling down the images from Docker Hub in this case. My application, you can actually put it onto, say, a private registry. In Google Cloud, we have a private registry you can also use, so that your images are secured within our projects and stuff like that. Okay, so there you go. That's how you deploy MySQL. And I can do a lot of these things, but because of the time, I'm just going to run a script that will go ahead and start all the full stack for me. So what this is going to do is to deploy MySQL if it wasn't deployed already, deploy Redis, deploy my guestbook service. And as this is going on, let me do a quick refresh here. Uh-oh. There we go. Oh, no. Yeah. So you can see my deployment. I have the front end that's being deployed. These are the 2 instances that's running the front end. It's managed by the deployment here, which manages 2 instances. And then the front end is talking to, you can see the arrow here, is talking to the guestbook service. They are also talking to Redis and Hello World service and such. And my guestbook service is talking to MySQL, so you can actually see some of these things visually. That's only through my custom visualizer. But notice here, the service, how do I actually access my application? All of the IP addresses so far is in the 10 dot whatever range, right? And all of these IP addresses are private. These are private IP addresses, okay? When you create a service to route your traffic, by default, it's going to create only the private IP address. If you want to expose it externally, you have to do that explicitly by saying that this service is of the type load balancer, okay? Without that type, it's going to create a cluster IP address, which is a private IP address. If you specify the type to be a load balancer, then depending on the environment that you deploy this to, it will actually create a real load balancer for you behind the scenes, a L7 or L3 load balancer for you. In Google Cloud, we actually create a real Google Cloud load balancer for you behind the scenes. On another cloud, they will actually create that load balancer for you. In your data center, for example, you can write APIs to create a load balancer with HA proxy or F5 or whatever else that you're using today. So I just deployed everything here, and I'm going to go ahead and see if I can get to it. Yes, I can. Yeah. So this is running in my Kubernetes cluster with 4 machines with multiple instances of the application and of my service. And if I'm lucky, this is being recorded. So this determines whether I keep my job or not. If I click on this greet button, come on. There we go. So I'm actually talking to MySQL right now behind the scenes through my service, and you can see that this is saying hello to me as well. And you can see that this is saying hello with version 1.0. What if I need to change this? What if I need to change this message? Right, remember, in my application, my message is being configured via a Spring Boot with application.property. So theoretically, I should be able to change that configuration file or by changing some kind of environmental variable to say something different. So I can actually do that. So I hope. So let me see here, get deployment. Okay, so I'm going to go back to this service, Hello World service. I'm going to say kubectl edit my deployment. Okay, and here I can actually see what's being configured. I can see the image. I can see everything. And in Spring Boot, I can override the configuration by environmental variable. So I can just go ahead and say inv, the name is greeting, if I recall correctly, and the value is hello from Lugano Ray with the name. Okay. Now, I didn't test this yesterday, but let's see how it works. Okay, so I'm going to refresh this, and I'm going to go scroll down to Hello World service. Now, watch very carefully. As soon as I save this, what the deployment, the blue box is going to do, I don't know if you saw it, it went by really quickly. It actually restarted my application for me with the configuration I just updated. Okay, it went by so fast. It's really hard to see. But now if I go back here and do a refresh, you can see that this is using a different message as well. Now, what if I need to update my application to another image? Well, that's very easy to do as well. Since I only have about 5 minutes, let me think of what I should do. I'm going to do something daring. So what I'm going to do is that I'm going to modify my UI. I'm not sure if this is going to work, so let's try it. I'm going to update the code here. I'm going to say background color. Marketing tells me that white background is no good, so I need to change it to light blue, for example. Right? Hopefully that's the right CSS code. I'm going to save that. And then what I can do, there is something wrong with my image, so let's try this. So what I'm going to do then is to create the image for this application. So I'm going to say something like darker build -t. My UI, let me see here, hello world UI, and with the current context, with the file I just updated. So hopefully this works. We'll see. We'll find out. Okay, so now it's building my application for me. So far, so good. It's resolving the dependencies, downloading everything that Spring Boot needs, and it's going to compile the files. And yes, it works. Okay, fantastic. Now I built a container. I can actually run this locally if I want to. But now I want to deploy it into Kubernetes. So the first thing I need to do is to tag it and push it to a repository. And because I'm running in Google Cloud, I'm going to go ahead and get my project name. Okay. So what I can do is I can do a Docker tag, the Hello World UI, into gcr.io, which is like a private registry you can get, with Google Cloud Platform, so you don't have to run your own. And I'm going to say Hello World UI v2, whatever. Okay. So I'm going to tag this image. And then what I can do is to push it into the registry. So I can do a gcloud docker push and push it. Okay? And what that's going to do is it's actually pushing from my Docker machine the image I just created and push it into the registry in Google Cloud, and then Kubernetes can get to that image when you want to do the deployment. There we go. 5 minutes, yeah. Now, if you ever play with Docker, you know that this step can take a long time. But no, I'm done already. Okay, fantastic. So here's the really daring part, is I'm going to run this. How do I update this so that I'm going to update my application to run with a new image, right? I can do it two ways. I can do a canary. I can actually deploy both versions of the application at the same time and getting routed by my load balancer to both applications. Why would you want to do that? You can test the application at a smaller scale, or you can do A/B testing if you want to, okay? Marketing tells you, hey, light blue is better, then you can say, let's try it. Let's deploy both and see which one is doing better. And for me, I'm just going to go ahead and deploy this to do a rolling update of my application. So this is a scary part. So right now, the background is white. And I'm going to go ahead and edit my deployment again. OK. And here I can say the image, I'm going to replace the image with v2. And rather than version 1.0, I'm going to say this is 2.0. Let me see if there's another 1.0 anywhere else. No? OK. All right, so wish me luck. So I'm going to save this. And now watch very carefully. In the UI, there you go. It's going to do a rolling update for me. And the way that you rolling update the application depends on the configuration as well. Right now, I'm saying that at most, I can tolerate one more instance than what I expected, which was 2. So now we have 3 instances. And I can tolerate one less instance of the running application, which was 1.0. So it's going to go through the step of taking an instance down and starting another instance for me very rapidly. Okay. So that went by a little bit too fast. There we go. So now if I go back to my application, if I do a refresh, let's see. Let's see if that works. What happened? Wait a second. Did I not? Wait. Let me check the source. Let me see if the background color is here. Oh, it's there, but you can see I probably used the wrong CSS color or something like that. So that is a bad deployment. That was a bad deployment. So that didn't work. Shoot, what do I do? By the way, this is not scripted, I promise. Like, I really expect it to work. But that's okay. So I can do a rollout. I can see a history. Oh, my God. Deployment. Hello, world. Oh, sorry. And see what the hell happened. Let me see here. Hello, world UI. And I can see my deployment history here. I can say, OK, somebody did a edit on my deployment. I don't want to do that anymore. So why don't we just go ahead and roll back. I'm going to say roll out, undo, deployment, hello world UI, and I should do it. And that will actually just roll back my application. If you go back to here, you can see it's doing another rolling update, reverting my changes from 2.0 to 1.0. Yeah, which is pretty cool. And then I'm just going to do one more thing here. I want to show you the real thing. So I'm going to edit my deployment again. Yeah. And let me see here, 1.0. Okay, so here we're then using that. I know this image works, v2, so I'm gonna go ahead and update it instead. So here we go. Oh, let me try that. v1 and v2. And now I edited my deployment again with the right image this time. Oh boy, live demos. And let's see if I refresh. And now this is actually, there are more than one instances running. So I don't know when it's going to route me to the right instance. But when this deployment is done, I hopefully should see the blue background. Okay? Because we're out of time, so you can check this IP address later. it should show up anytime now. Oh, there we go. Oh, thank goodness. Wow. Woo. Thank you very much. Thank you very much. Yep. Now, since I'm done with the demo, every magician has a disappearing trick. And for me to destroy this environment, I can just go ahead and code this script, turn down. It's going to delete all of my images for me from my Kubernetes cluster, will undeploy all the applications, and now I'm back to a clean slate so I can do my next talk. So thank you very much for your attention. So yeah, thank you. I'd be happy to answer any questions, but I know we're out of time. So yeah, what do you think? Yeah, any questions? No questions. Oh, that's good. Yeah. If you have any questions, feel free to grab me afterwards as well, or during lunch. So thank you.